Happy Friday to everyone. I just wanted to let you know we are starting the second part of our circle unit today. So what I have here is a copy of our calendar for the second half of the unit. You see here we're starting on Friday, May 2nd. We're going to be exploring lines that intersect circles. Some of our new vocabulary would be chord, secant, and tangents. We have worked with tangents before, so that's not brand new vocabulary. On Monday, we'll be taking a look at arcs and chords and central angles. And then on Tuesday, we're going to compare central and inscribed. On Wednesday, we'll look at all types of angle relationships with regards to circles, angles formed inside and outside. And then Thursday, we'll have review. And then next Friday, on May 9th, we'll have a quiz. Then after the quiz, this will be our last week of school where we don't have exams. We'll be looking at segment lengths and then arc lengths and then area of sectors. We have a performance task, which will be a graded group task that we do in class. Then you'll have 2 days of review. And then the last day of class, we'll have our test on this second part of unit on circles. And then you have 3 days of exams, but you guys just finished up taking your end of course test for this course, which counts as your exam grade, so you will not have a math exam. Okay, so let's just jump right in to today's lesson. And like I said before, we're going to discuss some key vocabulary, and this is out of your textbook, so if you happen to bring your geometry textbook, you can follow along with me. If you didn't, you just look at the screen and you can follow along that way. So we are on page 390 of our textbook, and we're looking at lines that intersect circles. So here is all the vocabulary that will be covered in today's lesson. And the first thing it talks about is the interior of a circle versus the exterior. Obviously, the interior is the inside, whereas the exterior is the outside. So we're going to have segments that are interior segments, and then we'll have some lines that are exterior segments. Recall that when we deal with circles, we have 2 ways of naming them. When they have a center C, we can call it circle C, or we can use the symbol for circle and call it circle C. All right, so let's just take a look at our vocabulary. This is at that bottom of the same page. So here they have defined the lines and segments that intersect a circle. So we have chord. A chord is a segment whose endpoints lie on the circle. So it's a segment, so it ends. And the endpoints of the chord are also parts of the points of the circle. And that is a chord. A secant is a line that intersects the circle in 2 points. So this blue line here is a secant because it intersects the circle in 2 points. A tangent is a line that intersects a line in the same plane as a circle that intersects in exactly 1 point. And we constructed tangents to circles, and we did that on our last test. The point where a tangent and a circle intersect is called the point of tangency. So this point here, point C, is your point of tangency. That's where the tangent line touches the circle. Now, there are some parts of the circle we've already studied. We've already studied the radius and the diameter. And so if we were to go in this circle, we'd have to have the center, and the radius connects the center to a point on the circle, and it doesn't matter which point we choose. So there's a radius, center, and then the diameter connects 2 points on the circle, and it is the longest chord of the circle is our diameter. So it passes through the center and connects 2 points of the circle is our diameter. So let's take a look at this one. Identify the lines and segments that intersect the circle. Okay, so let's just start right here. This line L. Line L, what would we call that? It is touching the circle in exactly 1 point, that point right there. So therefore, line L is a tangent to the circle. Now that point C is our point of tangency. That's where it touches the circle. Okay, then we have a chord here. We have a chord BC, and BC is not only a chord, but because it passes through the center, it's a special chord that we could also call the diameter. So most specifically, we would name that the diameter. And then for a radius, we could say AC or AB. Those are both radii. All right, and then we would have line EF is a secant because it passes through 2 points. Okay, take just a minute, and I have a you-try here for you. I would like you to identify what RQ is, what PQ is, what ST is, what line ST is. So segment ST versus line ST. And then we'll do line UV. And then point U. Point U. So take just a moment and identify all those with regards to the circle you're given. Okay, RQ. RQ is connecting 2 points on the circle. It is a chord. PQ. PQ goes from the center of a circle to a point on the circle. That makes it a radius. ST. Now this is segment ST. So segment ST would be most specifically defined as the diameter. Versus line ST, because it passes through 2 points, would be a secant. Line UV is a tangent line. And it is tangent at point U, so U would be considered the point of tangency. Okay, now that we're familiar with what to call all these different segments and lines within and outside a circle, let's see what we can do with them. Okay, pairs of circles. So here we have pairs of circles. Two circles are congruent if and only if they have congruent radii. So if we know that this radius is congruent to this radius, we know that circle A must be congruent to circle B. Now this if and only if we were using that, we could describe it as IFF, if and only if. So that means it goes both ways. So circle A is congruent to circle B if the radii are congruent, or we could say if the radii are congruent, then circle A must be congruent to circle B. So that if and only if, IFF, means it works both ways. All right, concentric circles. Concentric circles are coplanar, which means they lie in the same plane, and they have the same center. So circles that share the same center, and they end up looking like bullseyes. Two coplanar circles that intersect at exactly one point are called tangent circles. So here we have two circles that are tangent because they intersect right here in this one point. Now this is considered internally tangent, and this is considered externally tangent, and they share just one point. Now, we can also look at circles and draw in tangent lines. So we see in this first picture that circle A is circle B is internally tangent to circle A. We're asked to find the length of each radius. So from here to here would be 1, 2, 3, 4 units. So the radius of circle A is 4 units. And the radius of circle B is, let's count, 1, 2 units. Identify the point of tangency. The circles are tangent at that point. So that point, our point of tangency, is the point 3, 0. And then we're supposed to write an equation for the line tangent at that point, and they've already drawn it in for us. So tangent at that point is this vertical line. A vertical line is always x equals, and what is the x value at that point? 3. So the equation for the line of tangency, our tangent line, is x equals 3. Okay, you try number 2. So we're on page 391 in your book if you're with me. So take just a moment and identify the same things we identified here. If you would like to hit pause until the students are ready to move on. And then when they're ready, press play. Okay, looking at circle C, it has a radius of 1. Looking at circle D, it has a radius of 3. They are externally tangent here at this point, which is the point of tangency. Is the point 2, -1. And the equation for the tangent line is y equals -1. Okay, let's look at some lines and talk about common tangents. Common tangents are lines that are tangent to 2 circles. So here we have circles A and circle B, and we have common external and common internal. So if I were to ask you, how many common tangents do circles A and B have, we would say 4, because we have 2 external and 2 internal. Okay, here's a you try for you. I would like you to take these 2 circles, and these are a tangent, and I'd like you to draw in all the common tangents. So you can think about it or you can draw it in. How many do you think there are? Now, circle A and circle B up here had 4 common tangents. How many do you think these 2 circles have? All right, so let's take a look. If we were to draw these in, I'm going to try to use I'm a little off there. So we want it to be tangent to, there we go, close. And let's see if I can draw in this one. Close-ish. That's better. So that's 2 of them. Is that all of them? No, there's one that also goes right down the middle here. So I found 3. These 2 circles have 3 common tangents. 2 external and 1 internal. Okay, the next page is talking about some things that we have already constructed. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So here we have a line L, and if it is tangent, then they are perpendicular. Because L is tangent to circle A, then the radius and the line of tangency are perpendicular. And vice versa. If we have a radii that is perpendicular to a tangent, to a line, then we know it is tangent. So if it's perpendicular, then it's tangent. If it's tangent, then it is perpendicular. How can we expect to see these in problems? You might see one like this. It says RS is a radius of circle R. Is ST tangent to this? Okay, so we know if it's tangent, then this should form a right angle. If it forms a right angle, we have now created a right triangle, where a squared plus b squared must equal c squared. So if this is true, then we can say that ST is a tangent. So let's look at this. Okay, here's a leg, 5 squared. Here's a leg, 12 squared. Does that equal this leg? Ooh, I don't have all the parts for this leg. But if this radius has a length of 5, this radius must also be 5, because there are radii that exist within the same circle. So if we know that this is 5 and this is 8, the entire length is 13. And you guys are thinking right now, I don't even have to do Pythagorean theorem, Miss Willoughby. This is a Pythagorean triple. I know this is true, so we would say yes. ST is tangent. And we showed it because we proved that this is a right triangle, therefore RS is perpendicular to ST at this point, and ST is a tangent. Okay, you try the second one. When the class is ready, you can unpause it, but go ahead and press pause now. Okay, so this is what you should have set up for this one. You should have noticed that this was 12, so this would have been 19 squared. So it is 144 plus 256. Does that equal, 361. Okay, so what do you guys think? Is this a right triangle? No, it's not. They do not equal. So in this case, ST is not tangent. Whoops. Tangent. All right. Let's look at the third example for these. If AB is tangent, so this time they're telling me it is tangent, and they're asking me to find X. So if I know it is tangent, then this has to be a right angle. So now I have a right triangle. I know this is 9 because this radius is 9. So I know that 9 squared plus 40 squared is going to equal that X plus 9 squared. So 9 squared is 81, and 40 squared is 1600. So this gives me 1681. Now I want to solve for X, and right now everything's squared, so I'm going to take the square root. And since I'm dealing with lengths, when I take the square root, I'm just going to do the positive because it's a length. And we know we don't get negative. So we have 41 equals X plus 9. The square root of 1681 is 41. So then I just subtract 9 from both sides, and we get 32 equals X. So X is 32. This length from here to here is 32 units. That's what we get after we subtract 9 from both sides. Okay, let's look at one more theorem about circles. It says if two segments are tangent to a circle from the same external point, so we have AB and AC that are tangent to circle P from the same point A, then those segments are congruent. So if they're both tangent, then this would have to be congruent to this. So we can use that property. So if I told you that RS and RT are tangent to circle Q, and then ask you to find N. So if they are tangent, we know that this is congruent to this. So N plus 3 has to equal to N minus 1. So when we subtract N from both sides, we get that N, and we'll add 1 to both sides, is going to equal 4. N equals 4. Okay, guys, your classwork, and it really should be classwork if you work diligently for the remainder of class, is to open your geometry books to page 395. You're to do numbers 1 through 3, number 9, 11, 14, 18 through 22, 26, 27, 31, 33, 35, and 38 through 40. Because you're given plenty of time in class to work on these problems, there will be consequences if all homework is not completed on Monday. I hope you guys have a great weekend, and I hope you're excited about starting our our last unit for this year on circles. We'll see you Monday.